Hi everyone, thank you so much for coming to this video. So today we're going to be going over conditional probability. So please review the video on mutually exclusive and independent events, as that may come into use for this video. So the learning objective are to be able to understand and use a conditional probability formula, and also to understand how to use tree diagrams, Venn diagrams, and two-way tables. So I'm going to be explaining what the formula is, and giving you some two-worked examples to show you how to put them into practice. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So conditional probability is just the probability of something given something else has already happened. So this is the formula you have here. So if you were to work out the probability of event B given A, so probability B happening given that A has already happened, that's just the probability of B and A, the intersection of B and A, over just the probability of A. So you can think of this as well using a tree diagram. So if you have a tree diagram with your first branches as A and not B, and then here this branch would be probability of A, and then if you have your second branch being B or not B, then this branch over here, that's probability of B given the probability of A. So then if you were to work out the probability of A, of B and A, that would just be the probability of A times probability of B given A. So you remember that's just for tree diagrams to work out the probability of both A and B, you just add your two probabilities on your tree. So therefore if you rearrange this, you'd get the probability of B given A, that's the probability of B intersect A over the probability of A. So that's just how that's the formula for tree diagram and for conditional probability, and how this relates to the tree diagram. So let's try this with this example here. And we have Horace either walks W or runs R to the bus stop. The probability that he walks to the bus stop is 0.4. If he walks, the probability that he catches the bus stop C is 0.3. If he runs, the probability that he catches the bus is 0.7. We want to find the probability that Horace catches the bus. So first, our first branches of the tree that we want would be either walking or running. So if you fill in our probabilities, the probability that he walks to the bus stop is 0.4. So then as he either walks or runs, there's no other option. The probability that he runs is just 1 minus 0.4, so that'll just be 0.6. And then if he walks, then he can either catch the bus or not catch the bus. So those are your two options. That's your second tree and branches. So then if he walks, the probability that he catches the bus stop is 0.3. So he can either catch the bus stop or he can either not catch it. So then the probability that he doesn't catch the bus would just be 1 minus 0.3, so it'll just be 0.7. So here we have, using conditional probability, the probability that he catches the bus given that he walks is 0.3, and the probability that he doesn't catch the bus given he walks is 0.7. Now if he runs, the probability that he catches the bus if he runs, that is 0.7. So then because you can either catch or not catch the bus, probability that he doesn't catch the bus given that he runs is just 1 minus 0.7, so that's just 0.3. So that's all our components of our tree diagram. And now we want to find the probability that Horace catches the bus. So we want to find the probability of C. And we want to write that out in options. So that's the probability that he either walks and catches the bus, or the probability that he runs and catches the bus. So then the probability that he walks and catches the bus is the probability that he walks times the probability that he catches the bus given that he walks, plus the probability that he runs times probability that he catches the bus given that he runs. and that's just equal to 0.5 times 0.3 plus probability that it runs is 0.6 times probability that he catches bus given that he runs is this branch here times 0.7. So then that's just equal to 0.12 plus 0.42, which is just equal to 0.54. And that's the answer to this question. So that's how you could use conditional probability with a tree diagram. What you do is you just write out all your information on a tree diagram and just fill in the blanks with these, your second branches. Those are representing your conditional probabilities. And at this stage here, you can either write them out like I did using these formulas over here, or you could just do, if you know, just if whenever you're doing probability of W time and something, you just multiply along the branches. So you just do probability W times probability of here, so you just do 0.5 times 0.3, then you just add, because it's all, then you just do 0.6 times 0.7, so you just multiply along the branches. So that's how you could apply conditional probability to tree diagrams. Now let's move on to Venn diagrams. So moving on to Venn diagrams, so let's just quickly go over what a Venn diagram is and what everything represents. So you draw a Venn diagram by having two circles like this circle representing the probability of your event A, and this whole circle here representing the probability of your B. And if you were to write out what the probability of A union B, so that's probability of everything in A and everything in B, so A or B, then that would just be this whole shaded green area there. Then if you were to write down your probability of A intersection B, so the probability that an event is both A and B, so not either A or B, which was a union, but both A and B, then that would just be this blue bit in the middle, and that represents your probability of A intersect B. So then if you were to work out probability of A given B using probabilities, that would just be the probability of your whole A, which is that whole circle here, probability of A, plus the whole probability of your B, minus, because we've got an overlap, you want to minus your overlap in the middle again, so it's minus A given B. And then lastly, you have this bit on the edge, on the outside, so that's everything that's not in A or B. So this bit here, everything on the outside is just the probability of not A and the probability of not B. So everything that's not A and and the probability that's not in B. So that's everything of the Venn diagram. So now let's move on to a question to see if we can apply this, and also what we would do if we would have something that's using conditional probability. So we have a question here. Feel free to pause the video and try it out for yourself if you want. So we have a survey of the reading habits of some students reveal that on a regular basis, 25% read quality newspapers, 45% read tabloid newspapers, and 40% don't read newspapers at all. So we want to find the proportion of students who read both quality and tabloid newspapers. So we want to do the intersection of them both. So the first thing we want to do is we want to work out, first we just want to label everything. So we can have probability of Q. So that's just, let's label Q as quality newspapers. And we can have T as the tabloid ones. So then because we know that 40% don't read newspapers at all, then we know that 1 minus that would be the probability of those who read either quality or tabloid. So the probability of Q union T would just be equal to 1 minus 0.4, which is be equal to 0.6. So now we want to find the proportion who reads both quality and tabloid. So we want probability of Q intersection T. So we can rewrite Q union T as just probability of Q plus the probability of T minus probability of Q intersection T, and that would just be equal to 0.25 plus 0.45, which is equal to 0.6 minus probability of Q minus T. So therefore your probability of Q intersection T, that would just be equal to 0.1. So now we want to draw a Venn diagram to represent all of this information. So we can have quality here, tabloid here, then your box. So the outside is those who don't read any newspapers, so that would be 0.4. We have an intersection here, which is 0.1. Then the probability of Q, that would just be, that's just 0.25, but the bit that goes in this circle would just be 0.25 minus 0.1, which would be 0.15. And then we have our probability of T, which is 0.45, so that's this whole circle. But to get just this blank area here, it would just do 0.45 minus 1, which would be 0.35. That's our Venn diagram. And then part C is we want to, it says a student is selected at random. We want to find the probability that, so given that the student reads newspapers on a daily basis, we want to find the probability that the student only reads quality newspapers. So we want to say that we want to find the probability that they read quality newspapers given that they actually do read newspapers. So that is just the probability that they read, using this formula here, it's probability that they read quality newspapers and the probability that they read newspapers all over the probability that they read newspapers. So the probability that they read newspapers, that's just equal to the probability that they read the union of quality and tabloid. So that's just any newspapers that they're reading. So the intersection of Q and N, so that's just reading both quality newspapers and newspapers. So that's just the same as just reading normal quality. It will just be this bit. So only reading quality newspapers, not including your tabloids. So that would just be 0.15. And this will be over the probability of reading newspapers, which is just this whole area here, the whole union. So that's just over 0.6. And that will just simplify to 1/4. So that's your answer. So the first bit is just using your normal probability formula that we derived over here. Second bit was just drawing it out in your Venn diagram. That bit is where your conditional probability comes into use. So it's a probability of reading quality newspapers given that they're reading newspapers. So the intersection of quality newspapers and newspapers, that's just reading both quality and newspapers at the same time. So that's just the same as reading only quality newspapers. So we got that as 0.15. And the probability of reading newspapers, that's just probability of reading either quality or tabloid, so any type of newspapers. So we got that as over 0.6. So now that we've done Venn diagrams, let's move over to two-way tables. So the last type of way which we may have to apply conditional probability is through two-way tables. So two-way tables are just those that show relative frequencies for two types of events. So for example, in this one we have two-way tables showing activity choices, 3 types of activity choices, and then for 2 age groups and the frequencies and the relative frequencies for each of them. So for example, this 15 here represents those who are 14 and under and that who like to do swimming. So we have a question here. Feel free to try it out for yourself if you want to. We have the two-way table shows the ages and activity choices of a group of participants at a summer camp. A child is selected at random. Given that they choose rappelling, find the probability that this child is over 14. So let's label 2 events. So let's label A as being like rappelling, and let's label event B as being over 14. So we want the probability, so it's given that they choose rappelling, so the final probability that the child is over 14. So it's given that they do rappelling, find the probability that a child is over 18. So find probability of B given probability of A. So remember this line that represents your given. So whenever it's given something, whatever's given, that will go on your right hand side of your line. So now we want to do this just using a formula. So it's probability of B and A over the probability of A. So we want to find the probability of someone doing rappelling and being over the age of 14. So this will just be, that's just 24 and over the total amount of people. So if you add up, that'll be over 121 over the probability of A. So that's just the probability of rappelling. So that would be this whole column, which is 8 plus 24. So that's just 32 over 121, which is just equal to 24 over 32, which is just equal to 3 over 4. So that's your conditional probability. So we just want to write it out in conditional probability and just apply a formula. So for your probability of B and A, that would just be you'll just be on one column here, so the probability that they're rappelling and they're over the 14, so it's just your 24 value here, and then the probability over your probability of rappelling, so that's this whole column here, 8 plus 24, which is 32. So your answer is 24 over 32. So that's everything we wanted to cover. So now let's try another exam style question, just to make sure you can put some of this into practice. So we have an exam style question here, and feel free to pause the video and try it out for yourself first. So we have a keep fit enthusiast swims, runs or cycles each day with probabilities 0.2, 0.3 and 0.5 respectively. If he swims, he then spends time in the sauna with probability 0.35. The probabilities that he spends time in sauna after running or cycling are 0.2 and 0.45 respectively. The first thing we want to do is we want to represent this information on a tree diagram. So the first tree would have 3 branches. One would be swimming, one would be running, and one would be cycling. So swimming, run, cycling. This would go with probabilities 0.2, 0.3, and then 0.5. Then for each of them, I should call swimming SW, and then for each of them, it's either he'll go to the sauna or he won't go to the sauna. So let's do that for each of them. Sauna, not sauna, not sauna, and not sauna. So if he does swim, then the probability that he goes to sauna would be 0.35. So then the probability he doesn't go to sauna would just be 1 minus 0.35, which is just 0.65. Then if he runs, the probability that he goes to the sauna is 0.2. So then the probability he doesn't go to sauna if he runs is just 0.8. Then if he cycles, the probability that he goes to the sauna is 0.45. So then if he does cycle, the probability he doesn't go to the sauna is just 0.55. So that's everything in a tree diagram. So now next part is we want to find the probability that on any particular day he uses the sauna. So then the probability he uses sauna would just be the probability that he swims and uses sauna, or the probability that he runs and uses sauna, or the probability that he cycles or uses sauna. So that's just multiplying along the branch, so it'll be 0.2 times 0.35 plus 0.3 times 0.2 plus 0.5 times 0.45, and then if we apply that into our calculator, we would get that is equal to 0.355. So now if we move on to part C, it says given that he uses a sauna one day, find the probability that he'd been swimming. So you want to find the probability that he was swimming given he used the sauna. So that's the probability he was swimming and used the sauna all over the probability that he used the sauna. So you want to do probability of sauna and swimming, so that's just 0.2 times 0.35 all over the probability that he used sauna, which is what we calculated in the last question, which was just 0.355. So if you apply that in your calculator, you get that is equal to 0.19718. So now lastly, part D. Given that he did not use the sauna one day, find the probability that he had been swimming. So we're going to find the probability that he had been swimming given he did not use the sauna. So that's just the probability that he was swimming, and the probability he did not use sauna all over the probability that he did not use the sauna. So the probability he swam and did not use sauna, that's just 0.2 times 0.65. And then the probability he did not use the sauna, that's just 1 minus the probability that he did use the sauna. So just be 1 minus 0.355. So that would just be equal to 0.65 times 0.2 over 0.645. If you apply that in your calculator, you should get that's just equal to 0.20155. So that's your answer to this question. So the key to your conditional probability is just writing down what they've said in terms of conditional probability. So you always have the event that's given on the right hand side of your line, and everything else is on the other side. So you just use this formula here. So swimming given, use sauna is swimming and sauna over the probability that's sauna. So everything that's your denominator, that's always your thing that's given on your right hand side of your line. So yeah, other than that, that's how you solve tree diagrams. Just make sure when you have your question, you just write down everything accurately and make sure all your branches, like here, all of them, they do add to 1, because if they don't, you'll probably had a mistake somewhere. That's everything. Thank you so much, everyone. Hopefully you now understand and can use the conditional probability formula, and you can apply that to tree diagrams, Venn diagrams, and two-way tables. So make sure you do some practice questions just to make sure you fully understand how to do everything that we covered.